Okay, number 2. Like a number 1, I'm going to do a problem different than what I gave you on the test. So I'm going to give you the problem y equals 1 over x plus 1. Okay? So we're going to do y equals 1 over x plus 1. That should be fairly easy for you to graph. If I put in 0, 1 over 0 plus 1 is 1. So if I put in 0, I get 1. If I put in 1, I get 1 over 2, which is a half. If I put in 2, I get 1 over 3, or 1/3, and then 1/4. And so I get a graph that goes like this. So let's say I wanted to know the area under this curve revolved around the x-axis. So that this point would come up, around, and down. This point would come up, down, and around. This one come up, down, and around, etc. And I would get a piece over here where it's round this way. And let's say I wanted to find the volume of this rotated, looks like a chair leg sideways, from 0 to 3. 1 second. I gotta do something here. Okay. Since it's going this way, and there's no hole in it, a disk method would probably be the best method. Now remember that the disk method is integral of the, if you make, let's slow down here. If I make a slice, this thing is a round thing, so if I slice it, every time I slice it, I'm going to get a circle. Okay? Because it's revolved around the x-axis. So I need to know the volume of each of these these discs. Now the book says that formula is pi r of x squared dx. And that has confused some of you who have been reading the book, and you're thinking, okay, if it's r times x. No, that's not what it's saying. And that's why I don't use this notation. It's pi, the radius squared, but the radius has to be written as it using x's. That's what they're trying to say here. R is a function that has x's in it. We want to write r using x's. So this is not rx squared. It's r of x squared. The radius squared, but the radius has to be given as values of x. dx. And so x dx, the thickness of these slices, and each one of these will be x because we're slicing it this way, perpendicular to the axis. So the thickness of that slice is going to be a dx. That slice will be like a coin, if you will, a disc like that. Its thickness is dx, but it's a circular coin, and so it's like a cylinder, and the volume of a cylinder is pi r squared times the height. The dx is the height. The r squared is the area if you multiply by pi. So we're doing pi r squared dx, but r needs to be written as a function of x. Well, the radius of this coin that's sitting on its edge here is going up and down. So it's going to the curve, and the distance from the x-axis to the curve is a y height. So the radius is y. So the radius squared would be y squared times dx. And of course, the x is going to go from 0 to 3, so let me get those on there. But we were supposed to write the radius using x's. Well, the equation says the y is this in terms of x's. So we're going to use that for our x's. Oop, what happened there? Stop it. Get back on this one. Okay, so we need to write this y in terms of x's. So we're going to replace this y with 1 over x plus 1. So this becomes the integral from 0 to 3 pi 1 over x plus 1. That's the radius. That's y. The radius squared. That's the radius in terms of x. That's what they were trying to say there. Write it using x's. Dx. Pi is times the stuff and a number, so it can come out of the integral. So we've got to square this. So that would be pi integral 0 to 3 of 1 squared, which is 1, over x plus 1 squared dx. And I'm baking some bread, so I got to take the bread out of the oven. Sorry. Okay. Okay. Now you have to use what you learned in the last chapter. Make sure you're following all the things you need to know. This one looks like something that we can integrate by partial fractions. It's a repeated linear factor, so we put a over x plus 1 plus b over x plus 1 squared. Okay? And then we would type in, then we'd say this has to equal 1 over x plus 1 quantity squared. It has to be identically equal. The common denominator is x plus 1 squared. This one has the common denominator, so I don't need to multiply it by anything. Not even that. It has the common denominator. This one, to get the common denominator, I'd have to multiply by x plus 1 and x plus 1. So we're going to get, over this common denominator, we're going to get a times x plus 1 plus b is supposed to equal 1. So we have some x's here. So I'm going to say over here, no x's equals a plus, no x's here. So that's it, plus nothing. And then if I look at the constant, I have a 1. And over here I have a times 1, which is a plus b. So it looks like a has to be 0 and b has to be 1, and we don't get anywhere because we're right back to this. So how do we integrate that? Well, this is not working. So let's do a u sub. U equals x plus 1. du would equal dx. Oh, so this would be pi integral from 0 to, I'm changing to u. So it's no longer 0 to 3, but it's going to be 1 over u squared, and now dx is the same as du. And some people have been thinking anytime there's a denominator, it's ln. No, it's only if this is the denominator is like x to the 1 or u to the 1, it's to the 1 power. When it's 2, this is like u to the negative 2. To integrate it, you add 1, which makes negative 1, and you divide by negative 1. So the antiderivative of 1 over u squared is u to the negative 1 divided by negative 1. So we get pi integral, no more integral, of minus 1 over u. U to the minus 1 divided by minus 1. The minus makes it negative, and the negative here makes it 1 over u. Now, switching back to my x's, u was x plus 1. So I have minus 1 over x plus 1. Evaluated, I'm back in x's, evaluated from 0 to 3. So I put in 3, you put the top one in first, so I get pi 3 in here, 3 plus 1 is 4, so I get negative 1/4. Then I put in 0, and I get minus 1 over 1, which is minus 1, and I'm supposed to go minus, and it's a minus 1. This is minus 1, and I'm supposed to subtract, so that turns into plus. So I got negative 1/4 plus 1, which is 3/4 pi. And that's the volume of this. Okay.